All right, so in this question, we want to find the equation of a linear function that passes between 2 points. And this is a pretty standard question when it comes to building linear functions. We want to take a little bit of a different approach. Before we take that different approach, let's talk about what the typical way to do this problem is. So in method one, it's kind of the typical way that we approach it in algebra one and learn in algebra one, in that we're trying to identify the important parts of a linear function. And so those important parts are finding the slope, which we usually label as m, finding the y-intercept, which we usually label as b, and then plugging that info into a relevant form. And in this case, because we found m and b, the slope and the y-intercept, we want to plug that into slope-intercept form. So this is a typical way that we're taught in Algebra 1. It's the one that people are probably most familiar with. And it gives us a perfectly acceptable way to solve and find the equation of this linear function. What we're going to look at in this one is a different kind of approach, given that we have this given information. And it's one that if we're familiar with the approach, or if we make ourselves familiar with this quote unquote new approach, it is a little bit quicker. And that's what we're looking for. We're looking for efficiency. So let's go ahead and check that method out. So in this method, what I want to do is I want to recognize the information that I'm given. And what I'm given here is I'm given two different coordinate pairs. So I know that this is an x, and we're going to label this the first x and the first y. So this is just a coordinate pair. And then this is the second x and the second y. So we're just given two x, y coordinate pairs. And I want to use that and my understanding that, yes, y equals mx plus b is a perfectly acceptable form that we can use here. So method two involves first taking what we have and plugging it in to a known form. All right, so we'll go ahead and go through that process. I've got two xy coordinate pairs. I know that this is the form of a linear function, this y equals mx plus b. So let's go ahead and plug in what we know. We know that my y1 is 1, and that's equal to m times my x. So that's m times 3, or 3m. And I've still got this plus b tacked onto the end. And I also know I have another pair that's 2, that's my y2, and that's equal to m times 4, or 4m plus b. Okay, so what I've done is I've used the information that I know and a form that I know, and I've kind of married those two and come up with a system of equations. Now, this isn't a system that you're familiar with necessarily coming out of Algebra 1, because you're almost always taught that systems have x's and y's in them. But understand what we've created here. We have two equations, and within those two equations, we have two unknowns, two unknown variables. And those variables in this particular case happen to be m, which is the slope, and b, which is the y-intercept. And those are the two variables of interest anytime we're talking about a linear equation. So what we've done is created a system with the two variables of interest, and we can go solve these. And when we're solving them, we're actually coming up with information that's relevant to what we're trying to do. We're trying to find the slope and the intercept of this particular function. So from here, you solve it like any other system. It's substitution or elimination. In this particular case, I believe that elimination will be a little bit easier if we just subtract the bottom from the top. That would cancel or drop our b's. So we're going to subtract the bottom from the top. 1 minus 2 is going to give me a negative 1. 3m minus 4m is going to give me a negative 1m. And b minus b just drops off. That cancels these two. All right, I've just figured out what my slope is. My slope is going to be 1. There's that. And then I can use that to plug in to either one of these top equations. So 1 equals 3 times 1 plus b. And now I know my b is negative 2. So what's my equation? Well, just take that info, plug it in, and you get y equals mx, or just 1x minus 2, and there's my linear function.